Morning, ladies and gentlemen. We are going to do 4.3c today, which is solving quadratics by factoring. So we are going to solve a quadratic by factoring. So this is why we have spent so much time on factoring. Our objectives for the day are going to be to review factoring just a little bit more because it's very important. And then we are going to use the factoring to solve a quadratic. And we will actually do this for a couple of days because the solution to a quadratic is a little bit of a complicated process. It's a little bit different than solving a system of equations. All right, so a couple of definitions first. So we're first going to talk about a word, a monomial, which basically means it is an equation with one variable or one number. Okay, so mono means one, so a monomial is an expression, okay, I'll put expressions up here, that has one term. So a monomial has one term. Then a binomial is going to have two variables or two numbers or a combination of the two. Okay? Then the last one that we'll talk about is a trinomial, and it's going to either have three variables or three numbers. Okay? All right, so what I want to do first is go back and just review our factoring. Okay? So if we go back and review a factoring problem, and I'm going to do it both ways. I have x squared minus 9x plus 20. Notice this is a trinomial because it has three terms. Okay? So I can factor my trinomial into binomials. So that's what we're going to do. If I do guess and test, so there's my guess and test, the factors of 20 that are going to both have to have the same sign, and they're going to add to give me 9, is going to be x minus 5 and x minus 4. If I check, this gives me x squared, a negative 5x and a negative 4x gives me the negative 9, and a negative 5 and a negative 5 is a positive 20. Okay? For those of you that don't like to do guess and test, I'll do the AC method. So we already know what the factors are, so I'm just going to rewrite my middle term. So it's going to be x squared minus 5x minus 4x and then plus 20. Then if I do my grouping, okay, I'm going to get x is common to these and get x minus 5. These two have a negative 4 in common and I get x minus 5. And just a reminder, these are not multiplied together, they are added. Okay? Now this expression and this expression has an x minus 5 in common, and then if I factor it out, I get x minus 4. And then I got the same thing both ways. Alright? So let's just do another example, same idea. Let's do x squared plus 3x minus 12, and I want to factor that. Again, I'm going to do guess and test, so I want to find the factors that give me the middle term. Okay, so my combinations for 12 are 4 and 3, 6 and 2, 12 and 1. Do any of these add or subtract to give you 3? And the answer is no. So this one is not factorable. We can actually solve for x later, and we'll do the quadratic formula. but we're not going to do that today. So when we move on a couple of sections, even though I can't factor this expression, so I would write that it's not factorable, we will be able to solve it later by doing the quadratic formula. All right, so far in this particular chapter, we have talked about guess and test. We have talked about the AC method. And we've also talked about a difference, that's a C, sorry, of two squares, okay, of two squares. So those are the factoring methods that we have talked about so far. So we'll title that methods, okay. So today I'm going to add another method, and then we're going to solve some of our quadratics. All right. So let's just review the difference of two squares. It's a glorious method because it's super fast. Key thing for a difference of two squares is that there are only two terms, therefore it is a binomial. Okay. The first term is a perfect square. The second term is a perfect square. Therefore, the factors would be x plus 7 and x minus 7, because the square root of 49 is 7. All right, so now let's move on to our new method, and this one's called the perfect square trinomial. All right, this method is called the perfect square trinomial. And here's what it'll look like. Notice it says trinomial, so it'll have three terms. So I'll have a squared plus 2ab plus b squared. The first term is a perfect square. The last term is a perfect square. And then we'll talk about where this comes from. All right, to factor that, it's going to be a plus b quantity squared. So let me show you how they get that. So if I want to look to see if something is a perfect square trinomial, here are the keys that I look for. The first thing is that it's a trinomial. It has to have three terms. So it has to have those three terms. The next thing is that the first term is a perfect square, which means that I can take the square root of that. So the square root of a squared is a. All right. The last term also has to be a perfect square. All right, so my last term also has to be a perfect square, so that when I take the square root of that term, I get b. Then you need to look at the middle term. So if I take a, which was the square of the first term, and b, which is the square root of the last term, multiply those two things together and double it, then that gives me the middle term. Okay, and just to show you that the factor actually works, so if I expanded that using our little box that we've been doing just to illustrate, I would get a squared, ab, and b squared. When I combine my like terms along the diagonal, I would get a squared plus 2ab plus b squared. So if a trinomial meets the criteria, it's a very fast way to factor. All right, so let's do a couple of examples. All right, so the first one I want you to factor, and it's going to be x squared plus 6x plus 9. So here's going to be the process that we use to evaluate. X squared is a perfect square. So the square root of x squared is x. The last term is also a perfect square. So the square root of 9 is 3. If I multiply those two things together and double it, there's the middle term. So therefore, this is a perfect square trinomial, and it would factor to give me x plus 3 quantity squared. Okay? So let me just illustrate that it works, just to make you a believer. Okay, so I'm going to expand the binomial that we wrote as the factor. Okay, here's my box. Here's the x squared, 3x, 3x, 9. Combine like terms along the diagonal, and I get x squared plus 6x plus 9. So it did, in fact, work. All right. For the next one, let's do another example. So I want you to factor again, because we're kind of just living factoring right now. And I have x squared minus 4x plus 4. And again, I'm going to evaluate. The first term is a perfect square. So the square root of that is x. The last term is also a perfect square, and the square root of 4 is 2. If I multiply those two things together and double it, I get the middle term with just a different sign. So this is the 4x, so that when I factor this, it becomes x minus 2 quantity squared. And that manages the minus in the equation. All right, so now let's move on and start talking about why we factor. All right, so why factor? Factoring is a method to solve a quadratic. All right, and as we go, we'll get more and more information about the process. So factoring is a method to solve a quadratic. All right, but let's go back and talk about a system of linear equations, because we've already done this. So we want to go back and review this. So if I have two equations, I have y is equal to 2x plus 3 and y is equal to a negative 2x plus 6. To find the solution for these two equations, I would graph it. Okay. All right, so the first one had, let's say, a y-intercept of 3, and I go up 2 over 1. So there's 3. Okay, so I'm going to go up 2 over 1. So there's my first line. The second line had a y-intercept of 6, so there's the 6. And then it went down 2 over 1. And then I draw the other line. That point is the point of intersection, so the solution is where they intersect. The lines intersect. All right, so the solution was where the lines intersect. So for a quadratic, the solution is different, and we're not going to learn all of our information today, but we're going to talk about how I can solve it by using factoring. So now I want to solve a quadratic by factoring. Okay, so I'm going to solve my quadratic by factoring. So let's do an example. So if my example is solve, and then they give me x squared plus 7x plus 10, and it equals 0. Couple of things to notice about solving a quadratic is that I always need to have a 0 on one side and everything else on the other side. I can't have a number over here to solve. So it has to have a 0 on the right-hand side. So to solve this, I'm actually going to factor it. So I'm going to solve by factoring. So that means I need to factor it, which is why we've spent so much time factoring. The factors of 10 that give me 7 are going to be x plus 5 and x plus 2. All right? Each of these factors represents a baby equation that I can use to solve. So I would solve x plus 5 is equal to 0, and I would solve x plus 2 is equal to 0. When I solve this equation, I get x is a negative 5, and when I solve this equation, I get x is a negative 2. So now here is the first solution, here is the second solution. Okay? So when I solve a quadratic, you should always have two solutions. Okay? Just an extra piece of information If you notice back in the given equation, it was a second degree polynomial. The degree determines how many solutions you're going to have. So we had a second degree polynomial, and we got two solutions. The two solutions are x is equal to a -5 and x is equal to a -2. This process is called the zero product property. So if you see that word, not to be confused, but basically what it means is that I'm going to factor, set both of those equations equal to 0, and then solve, and that helps me find the solution. All right? So I'm just going to write down my word of caution. A quadratic can't be solved unless a 0 is on one side of the equation. Alright, so just like we did up above, I can't solve a quadratic unless I have a 0 on one side of the equation. Alright, a couple of other interesting facts. When we're asked to solve a quadratic, they use different words to say the same thing. So sometimes it will say, find the solutions. Sometimes it will say, find the roots. And then we will learn another one in a couple of days called the x-intercepts. Okay? So we use these three words interchangeably. Find the solutions, find the roots, find the x-intercepts. All right, so let's do another example. Okay? So here's our next example. All right, it says to solve. Doesn't tell you how, so we're going to solve by factoring. So I have x squared minus 5x minus 36 is equal to 0. I need to find the factors of 36 that subtract to give me 5. So 36 is 18 and 2, 9 and 4, 6 and 6, and 36 and 1. This is the only pair that subtracts to give me the -5. So my factors are going to be x minus 9, x plus 4 is equal to 0. The larger of the two numbers has to be negative. You could also do the AC method if that's helpful. All right, so now I can solve my two baby equations, and I say x minus 9 is 0, x plus 4 is 0, I get x is 9, and x is a -4. So those are my two solutions. All right, so it's actually fairly straightforward. All right, let's do another example because it's a little bit different. So this one's going to say solve, and it's going to give you a binomial. X squared minus 9 is 0. So there's actually two different ways that you can solve this. The first would be to factor that, and it's a difference of two squares, so I could solve this by factoring. Okay? So if I do that, my factors would be x plus 3 and x minus 3 is equal to 0. Solve the two baby equations, and I get x plus 3 is 0, x minus 3 is 0, x is a -3, and x is a +3. So those would be my two solutions. Okay? I can also do this by a process called extracting the roots, which is a weird saying that basically means take the square root of both sides. All right, so that's what extracting the roots says. So now I'm going to go back to my original equation. I'm going to take the 9 to the other side, so I'm going to add 9 to both sides, and I get x squared is equal to 9. Then I take the square root of both sides. The square root of x squared is x, and the square root of 9 is plus or minus 3. Every even root has two solutions. And those two solutions are plus or minus whatever the value is. Sorry. Okay? So every root has two solutions, so it's plus or minus the value. Let me show you how it works. If I have a positive 3 and a positive 3, I get 9. If I do a negative 3 and a negative 3, I also get 9. So every even root has two solutions. Even is the key word. We will do lots of different types of roots this year. Okay? All right, so unlike other days, your 3 problems are at the end. So here are your 3 problems. Okay? So when I get done writing them, you're going to pause the video. The video is actually over after you get to these 3 problems, and you're going to solve. So for each of these, I want you to solve. The first problem is x squared minus 11x plus 28 is equal to 0. The second problem says m squared plus 8m minus 65 is equal to 0. This one's a little harder because you have to figure out the factors of 65. You might try dividing by 5 to get started to find out what the factors are. And then the third one is x squared minus 64 is equal to 0. All right, so there are your 3 problems. So you can pause the video and get started.